On a clear, dark night, far from city lights, you can see it with your naked eye. A faint, ghostly smudge against the star-filled canvas of our night sky. What you're looking at is light that has traveled for over 2.5 million years to reach your eyes. You are seeing the past, and perhaps glimpsing our future. This is the story of Andromeda, our nearest major galactic neighbor, our cosmic twin, and our ultimate destiny. It's a tale of discovery, violence, beauty, and the inevitable dance of cosmic titans that will reshape the very fabric of our local universe. For over a millennium, humans have gazed upon this celestial wonder, not knowing they were looking at an entire galaxy containing 1 trillion stars. Tonight, we embark on a journey across 2.5 million light-years of space to explore the most important galaxy in our cosmic neighborhood, ancient eyes and modern revelations. Our story begins over 1,000 years ago, in the courts of ancient Persia. In 964 AD, the astronomer Abd al-Rahman al-Sufi was meticulously cataloging the night sky when he noticed something peculiar, a faint, nebulous star that didn't belong to any constellation. Al-Sufi called it Al-Sufi's Galaxy, though he had no concept of what a galaxy truly was. To him, it was simply a curiosity, a nebulous star that appeared different from the others. Centuries passed. European astronomers like Charles Messier cataloged it as M31, the 31st object in his famous catalog of comet-like objects. Still, no one understood its true nature. By the 1800s, improved telescopes revealed spiral structure in many of these mysterious nebulae. Lord Rosse's drawings showed elegant spiral arms, but the great debate raged. Were these objects within our own stellar system, or were they island universes, as philosopher Immanuel Kant had speculated? In 1920, astronomers Harlow Shapley and Heber Curtis engaged in what became known as the Great Debate. Shapley argued that spiral nebulae were local gas clouds. Curtis proposed they were distant galaxies. The future of cosmology hung in the balance. The answer came 5 years later, when a young astronomer named Edwin Hubble made the most profound discovery in human history. Using the powerful 100-inch telescope at Mount Wilson Observatory, he identified individual Cepheid variable stars within the Andromeda Nebula. These stellar lighthouses allowed him to calculate distance using a technique developed by Henrietta Swan Leavitt. The result was staggering. Andromeda was nearly 1 million light-years away, far beyond our own galaxy. In that moment, our universe became unimaginably larger. We were no longer alone in the cosmos, the anatomy of a giant. Today, we know Andromeda as one of the most magnificent objects in the universe. Officially designated M31, this galactic giant stretches 220,000 light-years from edge to edge, more than twice the diameter of our Milky Way. To put this in perspective, if you could travel at the speed of light, it would take you 220,000 years to cross from one side of Andromeda to the other. If you drove a car at highway speeds, the journey would take over 1.5 billion years. This cosmic leviathan contains approximately 1 trillion stars. That's nearly 3 times more than our own galaxy. These aren't just random points of light, but entire solar systems, many potentially harboring planets, and perhaps even life. The total mass of Andromeda is truly staggering, roughly 1.5 times that of the Milky Way, weighing in at about 1.2 trillion solar masses. But here's the mind-bending part. Most of this mass isn't in stars at all. Like all large galaxies, Andromeda is dominated by dark matter, that mysterious substance that outweighs ordinary matter by more than 5 to 1. When we observe Andromeda across different wavelengths of light, we're essentially doing archaeology. Each wavelength reveals different aspects. Ultraviolet shows us where new stars are being born. Infrared reveals cooler, older stars and dust lanes, while radio waves map out the hydrogen gas that fuels star formation. Like our galaxy, Andromeda is a barred spiral galaxy with elegant arms of stars, gas, and dust sweeping outward from its central bulge. But Andromeda's structure is more complex than our own, with multiple ring-like formations and what astronomers call a double nucleus at its center. The stellar generations. Not all stars in Andromeda are created equal. Like people, they come in different generations, each telling a story about the galaxy's past. The oldest residents are ancient red giants and the stars in globular clusters, dense balls of hundreds of thousands of stars that orbit the galaxy like cosmic cities. These stellar ancients are over 10 billion years old, formed when the universe was less than a quarter of its current age. In stark contrast, the spiral arms blaze with young, hot blue stars, some less than 1 million years old. These stellar newborns are born in vast nebulae, where gas and dust collapse under their own gravity. By studying the stellar populations in Andromeda, we can reconstruct its entire history. The metal content of stars, what astronomers call metallicity, tells us when they formed. Early stars had almost no heavy elements, while newer generations are enriched by the deaths of previous stellar generations. This cosmic recycling program has been running for billions of years. When massive stars die in spectacular supernova explosions, they scatter heavy elements, carbon, oxygen, silicon, iron, into space. These elements become the building blocks for new stars, planets, and eventually, life itself. Even smaller stars contribute to this cycle. When stars like our Sun die, they puff off their outer layers, creating beautiful planetary nebulae while leaving behind dense white dwarf cores. These stellar corpses slowly cool over trillions of years, becoming the fading embers of cosmic history. A violent galactic history. Andromeda didn't always look as serene as it does today. Beneath its elegant spiral structure lies a dark and violent history. This galaxy is a cosmic cannibal that has devoured multiple smaller galaxies over billions of years. The evidence is written in streams of stars that orbit Andromeda like ghostly ribbons. These are the remnants of smaller galaxies that were torn apart by Andromeda's immense gravitational pull, their stars scattered but not forgotten. The most prominent of these is the giant stellar stream, a river of stars that extends for hundreds of thousands of light years around Andromeda. This is all that remains of a galaxy that was completely destroyed, its stars now forever trapped in orbit around their destroyer. When we look at Andromeda's stellar population, we can see the archaeological record of its past. Different generations of stars tell us about different merger events. We can actually identify at least 30 distinct merger events in Andromeda's history. It's like reading the chapters of a very violent book. Perhaps most shocking of all, scientists now believe that Andromeda collided with and completely absorbed a galaxy nearly as large as the Milky Way about 2 billion years ago. This wasn't a gentle merger. It was a cosmic catastrophe that fundamentally reshaped Andromeda. This ancient collision explains many of Andromeda's unusual features: its warped disk, its complex stellar populations, and even its double nucleus. The smaller galaxy didn't go quietly. It left its mark on every aspect of Andromeda's structure. Today, Andromeda still has companions, smaller galaxies called M32 and M110 that orbit like cosmic pets. But their fate is sealed. Eventually, they too will be consumed by their massive parent, adding their stars to Andromeda's already impressive collection. The central monster. At the heart of Andromeda lurks one of the most massive and mysterious objects known to science, a supermassive black hole containing the mass of 100 to 200 million suns. That's 25 to 50 times more massive than Sagittarius A star, the black hole at the center of our own galaxy. This gravitational monster anchors the entire galaxy, its immense pull keeping 1 trillion stars in their cosmic dance. The black hole's event horizon, the point of no return, is larger than the orbit of Earth around the Sun. Supermassive black holes are like the conductors of a galactic orchestra. They don't just sit there passively. They actively shape the evolution of their host galaxies through feedback processes that can trigger or shut down star formation across vast regions. But Andromeda's central region holds another mystery. High-resolution observations reveal what appears to be a double nucleus, 2 bright concentrations of stars near the galaxy's center. For years, astronomers thought this might be 2 supermassive black holes, but we now believe it's an optical illusion created by a ring of stars orbiting the single central black hole. Unlike some supermassive black holes that shine as brilliant quasars, Andromeda's central beast is relatively quiet. It's not actively feeding on large amounts of matter. If it were, Andromeda would blaze so brightly that it would dominate our night sky, possibly even being visible during the day and sterilizing any nearby planets with radiation. The region around this black hole is one of the most extreme environments in the galaxy. Stars zoom around at thousands of miles per second, and occasional stellar collisions create exotic objects like blue stragglers, stars that appear younger than they should be. The cosmic neighborhood. Andromeda doesn't exist in isolation. It's part of our cosmic neighborhood called the Local Group, a collection of more than 80 galaxies bound together by gravity across a region spanning roughly 10 million light-years. The Local Group is dominated by 3 large spiral galaxies, our Milky Way, Andromeda, and the smaller but still impressive Triangulum Galaxy, also known as M33. These 3 giants are surrounded by dozens of smaller satellite galaxies, dwarf ellipticals, dwarf spheroidals, and irregular galaxies. Andromeda alone has over 20 known satellite galaxies, with new ones being discovered regularly. These cosmic companions range from the relatively large M32 and M110 to tiny, ultra-faint dwarf galaxies, containing just a few thousand stars. The Local Group is like a fossil record of how structure formed in the early universe. By studying the orbits and properties of all these galaxies, we can understand how they came together over billions of years through gravitational attraction. The entire Local Group is embedded in an enormous halo of dark matter, that mysterious substance that makes up 85% of all matter in the universe. This dark matter scaffolding guided the formation of galaxies, creating the cosmic web of structure we see today. But even the Local Group isn't the end of the story. Our entire galactic neighborhood is being pulled towards something called the Great Attractor, a massive concentration of galaxies and dark matter that's drawing us across space at over 1,000 miles per second, the approaching giant. Here's something that might fundamentally change how you think about the future. Andromeda is heading straight for us. Unlike most galaxies in the universe, which are moving away due to cosmic expansion, Andromeda is approaching the Milky Way at 250,000 miles per hour, fast enough to travel from Earth to the Moon in less than an hour. This discovery required some of the most precise measurements in astronomy. Scientists had to detect Andromeda's motion across the sky, its proper motion, which is incredibly tiny due to the vast distance. It's like measuring the width of a human hair from 2,000 miles away. In approximately 4.5 billion years, these 2 galactic titans will collide in what scientists call the most spectacular event our solar system will ever witness. But don't panic, this won't be a destructive crash like 2 cars colliding. When we say collision, it's misleading. Galaxies are mostly empty space, The stars are so far apart that very few, if any, will actually collide. Instead, they'll be redistributed into new orbits through gravitational interactions. It's more like two swarms of bees merging than two solid objects crashing. The collision will unfold over billions of years in a cosmic ballet of unimaginable complexity. First, the outer regions of both galaxies will begin to distort as their gravity fields interact. Tidal streams of stars will be flung into space, creating spectacular bridges and tails of stellar debris. As the galaxies interpenetrate, their gas clouds will collide at high speeds, creating shockwaves that trigger massive bursts of star formation. The night sky will blaze with newborn stars, many of them hot blue giants that will burn brightly but briefly. The climax will come when the two supermassive black holes at the galactic centers finally merge, creating gravitational waves that will ripple across the universe. This merger will birth one of the most massive black holes in the local universe. The result will be a new elliptical galaxy that astronomers have already nicknamed Milky-Way. This cosmic hybrid will be larger than either of its parent galaxies, containing nearly 2 trillion stars in a roughly spherical distribution. Fate of our solar system. What will happen to our solar system during this cosmic merger? The answer depends on where we end up in the gravitational chaos of the collision. Computer simulations suggest that our Sun has about a 50-50 chance of being ejected from the central regions of the merged galaxy. We might find ourselves in the outer halo of Andromeda, far from the galactic center where we currently reside. The good news is that the Sun will likely survive the merger relatively unscathed. The bad news is that we might end up in a very different neighborhood, possibly in the outer suburbs of the new galaxy, where the night sky would look completely different. The night sky will be transformed beyond recognition long before the merger is complete. As Andromeda approaches, it will grow larger and larger in our sky. Instead of the faint smudge we see today, our descendants will witness a spectacular galaxy filling much of the night sky. During the height of the collision, the sky will be ablaze with star